Dear First Secondary, Assalamu alaikum wa rahmatullah wa barakatuh. It's Mr. Ahmad Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Algebra. It's Unit 1, Lesson 2. The lesson is called an Introduction in Complex Numbers. In this lesson, we are going to learn what the meaning of the complex number and what is the components of the complex numbers, and it depends on the real numbers and a new set of numbers called imaginary numbers. Okay, and we are going to solve many problems about this one. Let's start the lesson. First, we need to know what the meaning of the imaginary numbers. Okay, for example, if we have equation like this, x power of 2 equal 0. If we need to solve this equation, so we are going to send 1 to the other side as minus 1. Okay, but first I'm going to distribute this one graphically to be like this. Here we have x-axis and y-axis. The graph will be like this. Is a U-shape, intersect y-axis at 1, and this line doesn't intersect x-axis. Okay, so we haven't here any solution, because the solution, as I explained in the last lesson, is the intersection of the curve with the x-axis. Okay, back to the equation x power of 2 plus 1 equals 0. I'm going to send 1 there to the other side to be negative 1. So I will take the square root for the two sides like this. But as I said before, the square root for the negative number is meaningless. So here the solution set in R is phi. Okay, this is the uses of the imaginary number. What is the imaginary number? The imaginary number is we represent, or we let that root negative 1 is called I. So this is the solution for, or this is the solving for this equation. Okay, what is the imaginary number? The imaginary number I is root negative 1. Again, I is root negative 1. Okay, let that root negative 1 is a number, and this number is called I. So we have a solution for this equation like this: x equal negative or positive I. Okay, now back to this equation. This equation in R has no solutions, and before we used to write the solution set in for this equation is phi. Why? Because root negative 1 is meaningless in the real number. But now, okay, we imagined that root negative 1 is a number, and this number is called I, abbreviation of imaginary. So now we have a solution for this equation. Okay, this solution is negative or positive I, and the solution set in this case equal negative I or positive I. Don't forget what is I. I is root negative 1. Okay, now let's study the rules of the imaginary number I. Okay, this was an introduction for the meaning of the imaginary number. Okay, because we have here this curve doesn't intersect the x-axis there, then there is no solution in the real numbers. And because root negative 1 is meaningless in the real numbers, so there is no solution in the real numbers, we imagined that root negative 1 equal I. Then we have now a solution for this equation. Okay, back to the imaginary number I. I to the power negative 1 as usual equal I. Okay, what if we have I to the power of 2? I power of 2 means negative root negative 1 all power of 2. Okay, as we studied before, power of 2 cancelled the root. Again, power of 2 cancelled the root. Then power of 2 will cancel the root like this. Then the equal will be negative 1 like this. Then we can say that I to the power of 2 equal negative 1. Okay, I to the power of 3 equals I power of 2 times I. Again, I power of 3 equals I power of 2 times I. But I power of 2, as I said, I power of 2 equals negative 1. So we will put in place of I power of 2 negative 1, it will be negative 1I. Finally, it equals negative I. So I power of 3 equals negative I. Finally, I power 4. I power 4, which is equal I power of 2 times I power of 2. I power of 2 equal negative 1. And I power of 2 equal negative 1. It will be negative 1 times negative 1. Negative 1 times negative 1 equals 1. So I power 4 equal 1. Now, this is the rules of the imaginary number I. I power 1 equal I. Power 2 negative 1. Power 3 negative I. Power 4 equals 1. Okay, now this is what you have to study or what you have to keep. But now we are going to conclude how can we find I power 5, I power 6, I power 7 and so on. For example, if we have, for example, as I said, for example, if we have I power 5, I power 5 equal 4 plus 1. Again, I power 5 equal 4 plus 1. Okay, I power 4 times I power of 1. As we said, I power 4 equal 1. So we will put in place of I power 4 1. It will be 1 times I. 1 times I equals I. Finally, I power 5 equals I. Okay, you don't have to keep this one. You just need to remember I power 1, 2, 3, and 4. Okay, I power 6. I power 6 equal I power 4 times I power of 2. I power 4 equal 1 and I power of 2 equal negative 1. So I power 6 equal negative 1. I power 7. 7 equal 4 plus 3. It will be 1 and I power of 3 equal negative I. It will be 1 times negative I. 1 times negative I equals negative I. So I power of 7 equals negative I. I power of 8 equal I power 4 times I power 4 equals 1 times 1 equals 1. So, by looking carefully here, I power 4 equal 1. I power 8 equal 1. What is the relation? 4 and 8 are the numbers which called multiples of 4, or numbers divisible by 4. So, I to the power any number divisible by 4 equals 1. For example, I power of 12 equal 1 because 12 equal 4 times 3. I power of 16 equal 1 because 16 equal 4 times 4. I power of 20 equals 1. I power 24 equal 1. I power 28 equal 1 and so on. So any power divisible by 4 or in table 4 or multiple of 4 equal 1. Don't forget this one. Okay, now let's solve the next question. Put each of the following in the simplest form. First, we will start with I power negative 26. Okay, I power of 26. The way now to solve this one, I'm going to search for number divisible by 4 nearest to 26. Okay, 26 is not divisible by 4. 25 is not divisible by 4. 24 is divisible by 4. So I will change 26 like this to be I power of 24 plus 2. Why 24? Because 24 is divisible by 4. Okay, so it will be I power of 24 times I power of 2 equals I power of 24 equals 1, I power of 2 equals, don't forget, I power 1 I power 1 equals 1, I power of 2 equals negative 1, I power of 3 equals negative I power of 4 equals 1, and all the numbers in table 4 divisible by equals 1. Okay, now back to our example. I power of 2 equal negative 1, so it will be negative 1. Finally, it equals 1 times negative 1 equals negative 1. Okay, now the next one, I to the power 43. I to the power 43, 43 is not divisible by 4. So I will search about number divisible by 4. 42 is not divisible by 4. 41 not divisible by 4. 40 is divisible by 4. So it will be I to the power 40 plus 3. I power 40 equals 1. So it will be I power of 3. I power of 3 which is negative I. Okay, the next one. I to the power 105. 105 is not in table 4. 104 is in table 4. So it will be I power 104 plus 1. I power 104 equals 1. So it will be I to the power of 1. And I power of 1 equals I. The next one. I to the power 4n plus 29. It's equal. Here 4n, any number times 4 is multiple of 4, and this one equal 1. So I will cross 4n. Okay, it will be I to the power of 29. I to the power of 29, 29 is not divisible by 4, but 28 in table 4. So it will be I to the power 28 plus 1. Cross 28, it will be I power of 1, and I power of 1 equals I. Okay, number 5. I to the power of negative 30. I to the power of negative 30 equals, here we have two different ways for the power, for the negative power. Okay, now I will search about positive number greater than positive number in greater than in table 4 and in the same time greater than 30. Okay, this 30 is not divisible by 4. 31, 32 is divisible by 4. So it will be I power of 32 times I power negative 30. How come? I power 32 equals 1, and any number to the multiply by 1 doesn't change, so it is equal 1. Okay, then the value doesn't change. Okay, here it will be 32 plus negative 30 equal 2. It will be I to the power of 2. I to the power of 2 equals negative 1, as we said before. Okay, another one. I to the power negative 45. I'm going to search about positive number greater than 45 in table 4. 45 is not in table 4. 46 is not. 47 is not. 48 is in table 4. So it will be I to the power 48 times I to the power negative 45. I power 48 equals 1. Okay, it will be I to the power 48 plus negative 45 equals positive 3. And I to the power 3 equals negative I. Okay, here 1 over I to the power of 9. Okay, this is the same way I used in the negative powers. I will change 1 into I to the power number in table 4. Okay, but greater than 9. 9 is not in table 4, 10 is not in table 4, 11 is not, 12 in table 4. Then it will be I to the power of 12 over I to the power of 9. 12 minus 9 equals 3. It will be I to the power of 3, which is negative I. Okay, number 8. I to the power 4n plus 42. I will cross 4n. 42 is not in table 4. 41 is not. 40 is in table 4. So it will be 40 plus 2, which is I to the power, I will cross 40, I to the power of 2, which is negative 1. Let's solve example 2. Now in this example, put in the simplest form. Okay, root negative 15. Okay, it will be root negative 1 times root 15. Why root negative 1? Because root negative 1 equals I, so it will be root 15I. The next one, number 2, root negative 18 times root negative 12. Okay, this one equal root negative, this one root 18I times root 12I. Okay, now root 18 times root 12 equal 6 root 6. I times I equals I power of 2. Don't forget that I power of 2 equals negative 1. Then this one equal negative 6 root 6. Remember with me, I power negative 2 change the sign. Again, I power negative 2 change the sign. Okay, if the number is positive times I power 2, it will be negative, and if the number is negative times I power of 2, it will be positive. Okay, the next one, 3i times negative 2i. 3 times negative 2 equals negative 6. I times I equals I power of 2. And as I said, I power of 2 change the sign, it will be positive 6. The next one, here number 4, negative 4i times negative 6 equals negative 4 times negative 6 equal 24, positive 24, and I times I equals I power of 2. Remember, I power of 2 change the sign, it will be negative 24i. Negative 2i all power of 3, negative 3i all power of 2. Okay, now I will distribute the power here and distribute the power here. Okay, negative 2 all power of 3 equals negative 8 I power of 3 times negative 3 all power of 2 equals 9 I power of 2. So negative 8 times 9 equal negative 72. I power of 3 times I power of 2 equals I power of 5. Okay, and it will be negative 72 I power 4 plus 1. I will cross 4. It will be I power of 1. So finally it will be negative 72 I. Now we are going to study the set of complex numbers. As I said, the lesson included set called complex numbers. This set depend on the imaginary numbers, as we studied in the beginning of the lesson. Okay, now let's know what is a complex number. From its name, complex numbers. Okay, complex numbers is numbers included two types of numbers, the real numbers and the imaginary numbers. So we called it complex because it contains two different types of numbers. Okay, the complex numbers denoted by C equals the real numbers union the imaginary numbers. All the real numbers plus all the imaginary numbers in one set called C. This is the complex numbers. Now let's remember the sets of numbers as we studied from the primary stage and the prep stage. N, which is equal 0, 1, 2 and 3 and so on. N totally is inside set called Z. Z included the natural numbers plus the negative numbers. Okay, now N and Z totally inside set called Q, which is a set of rational numbers. Q included positive numbers and the negative numbers or whole numbers plus the fractions and decimals. Okay, now there is another set opposite to Q called Q dash. Q dash included the roots and pi. Q and the Q dash together called R. Again, N and Z and Q dash, all of them inside R. And R, we have a new set called I. I is a set of imaginary numbers which included 2i and negative 3i and so on. Okay, now the set of real numbers and its components plus the set of I or imaginary numbers inside a set called complex numbers. The complex numbers, the set denoted by C. Now we are going to study the complex number. The complex number denoted by small c. Okay, this number formed from two parts, A plus BI, where A is a real part and B is the imaginary part. Okay, if A equals 0, then the number called pure imaginary. If B equals 0, then the number is called pure real. And if A and B not equal 0, so the number called complex number. Again, the number A only called pure real. The number BI called pure imaginary. The number A plus BI called complex number. Don't forget, remember with me, that x plus y all power of 2. In this one, to expand this bracket, we have two ways. Okay, you may expand this one into two brackets and multiply them, x plus y times x plus y, or by using the next rule, and I prefer the rule, okay, first power of 2, which is x, and 2 times first times second, 2xy, and second power of 2. Remember with me, this is a very, very important remark. X power of 2 plus 2xy plus y to the power of 2. Now let's solve the next question. Example 3. Put the following in the simplest form. Number 1, 3 plus 2i plus 2 minus 5i, like this. Okay. To solve this one, 3 plus 2 equals 5, and 2i plus negative 5i, 2 plus negative 5 equal negative 3i. Okay. The next one, number 2, 12 minus 5i minus 7 negative 9i. Okay, 12 minus 7, I'm going to take the real with real and the imaginary with imaginary. 12 minus 7, 12 minus 7 equal 5. Okay, negative 5 minus 9 again. Negative 5 minus 9 equal positive 4 plus 4i. Number 3. Here I have to expand the brackets. How can we expand the bracket? By using the distribution method. Okay, now I'm going to expand the first one like this. 2 times 3 and 2 times 4i, 3i times 3, 3i times negative 4i. Okay, that's equal 2 times 3 equal positive 6, 2 times negative 4i equal negative 8i, and 3 times 3 equal positive 9i. 3 times negative 4 equal negative 12, but I times I equals I to the power of 2. Okay, now I'm going to simplify this one. Here we have 6, negative 8 plus 9 equal positive 1i or positive I. Negative 12 times I power of 2, as I said before, I power of 2 change the sign, so it will be positive 12. Don't forget 6 and 12 are like, then it will be 18 plus I. Okay, now I need to use the calculator to simplify this one. Okay, this is the calculator. I will write mod complex or mod 2 like this. It will write here complex. Okay, now open bracket, 2 plus 3 I is here eng. This button is the button of I like this. Then I will close the brackets and the new bracket, 3 minus 4 I, and close the bracket. It will be 18 plus I. This is the simplest form. You can use the calculator to check, or if the question is complete or choose, then you can simplify directly by using the calculator. It's okay. Okay, number 4, 4 minus 3i times 4 plus 3i. Those two numbers called two conjugate numbers. We multiply the first by the first and the second by the second, okay, without distribution. First time first and second time second, like this. 4 times 4 equals 16. Negative 3 times positive 3 equal negative 9. I times I equals I power of 2. But I power of 2 changes the sign. It will be 16 plus 9 equals 25. You can check by using the calculator. 2 plus negative 5i all power of 2. As we studied before, the bracket power of 2, first power of 2, which is 2 power of 2 equal 4, and 2 times first times second, 2 times negative 5, 2 times 2 4, times negative 5 equal negative 20 I, and second power of 2, negative 5 power of 2 equal positive 25 I power of 2. Okay, don't forget the rule as I explained in the last time. Okay, now for negative 20 I, 25 I power of 2 changes the sign. It will be negative 25. Okay, 4 minus 25 equal negative 21. It will be negative 21 minus 20 I. Okay, number 6. 1 minus I all power of 10. Now this one, I will change 10 into 2 times number. 10 here equal 2 times 5. It will be 1 minus I all power of 2 all power of 5. Then I will simplify 1 minus I all power of 2, then raise the number to the power of 5. Okay, it will be 1 power of 2 equals 1, 2 times first times second equal negative 2 times 1 equal 2 times negative I equal negative 2I, negative I power of 2 equal positive I power of 2 all power 5 equals 1. Here I power of 2 equal negative 1. 1 negative 1 and 1 equals 0. So I will cancel I power 2 with 1 because I power of 2 equal negative 1. Negative 1 plus 1 equals 0. Okay, and then I will continue the solution. It will be negative 2I all power 5. Now I'm going to distribute the power 5. Negative 2 power 5 equal negative 32 I power 5. I power 5, 5 equal 4 plus 1. It will be like this, equal negative 32 I power 4 plus 1. We cross 4. It will be negative 32I equal negative 32I. Now let's solve example 4. Solve the following equations in the set of complex numbers. Now, in the complex numbers, we haven't included the real and the imaginary numbers. Okay? It gives you the flexibility to solve any equation. Okay, now to solve this equation, I'm going to send 12 there with minus. It will be 3x power of 2 equals negative 12. And I'm going to send 3 there divided. Here it will be x power of 2 equals negative 12 divided by 3 equal negative 4. Then by taking the square root for both sides, then x equal root negative or positive root negative 4. Root negative 4, which is root 4 I. Root 4 equal 2, okay, and root negative 1 called I. So it will be negative or positive 2 I. So the solution set equals 2I and negative 2I. Okay, the next one. X power of 2 minus 4x plus 5. Okay, here I can't factorize this one, so I have to use the formula or using a calculator, but I will use the formula a equal 1, b equal negative 4, c equal 5. So x equal negative b, which is 4, positive or negative, square root negative 4 all power of 2 equals 16 minus 4 times 1, which is a, times 5, which is c, over 2 times 1, which is a. So x, I will write this one on the calculator. So x1 equals 2 plus I, and the other x equals 2 minus I. Okay, by using the calculator, I will solve this one by using the calculator to show you how can the calculator solve the set on the complex number, the equation in the complex number. Okay, mod 5, 3, a, b, c, a 1, b negative 4, c 5, 1 equal, negative 4 equal, 5 equal, x1 equal 2 plus I, x2 equal 2 minus I. Okay, now we have the flexibility to solve the equation because this numbers belongs to the set of complex numbers 2 plus I, comma 2 minus I, and this is the solution set. Okay, number 3, a equal, I'm going to use the calculator directly because, okay, I explained this one here. A4, B negative 1, C 1. So 4 equal, negative 1 equal, 1 equal, x equal 1 over 8 plus root 15 over 8I, and 1 over 8 minus root 15 over 8I. Okay, x equal 1 over 8 plus root 15 over 8I. The other x equal 1 over 8 minus root 15 over 8I, and the solution set. Okay, you know the answer. Okay, now let's study the two conjugate numbers. We studied before the two conjugate numbers in the second prep. The two conjugate numbers are two numbers written in the form a plus b and a minus b. That's what we studied in the second prep. But now we are going to study the two conjugate numbers included imaginary number. It will be like this: a plus bi and a minus bi. Those two numbers are two conjugate numbers. Now let's study how can we add the two conjugate numbers. But don't forget, the positive and the negative must be, or the two different signs must be the two imaginary parts. Okay, for example, if we have I plus 1, its conjugate must be negative I plus 1. You have to change the sign of the imaginary, not the real part. This is a very important remark. Okay, Now let's add the two complex numbers, a plus bi, the two imaginary numbers. Okay, it will be a plus a equal to a, and bi plus negative bi equal 0, then it will be 2a. Now its real part, the sum of the two conjugate numbers equal real number. Okay, now let's study how can we multiply the two conjugate numbers. If we multiply them, I'm going to multiply the first times the first, a times a equal a power of 2, and the second times the second, bi times negative bi equal negative bi power of 2. But I explained before that the I power of 2 change the sign, it will be positive b power of 2 like this. Okay, you can solve it by steps, it's okay, but this is the rule of how can we multiply two conjugate numbers. But by looking carefully to the answer, it will be a power of 2 plus b power of 2. This is also a real number. So the two conjugate numbers, the sum of them equal real number, and the product of them equal also real number. Okay, now let's solve the next question. Here in this one we have put each of the following in the simplest form, 4 plus I over I. Okay, to simplify this one, we are going to multiply up and down times I, because I times I equal negative 1, it will be real number. The purpose of simplify this one, change the denominator into real number or positive whole number. Okay, it will be negative I times I equal I power of 2, which is negative 1. Okay, 4 times I equals 4i. I times I equal I power of 2, which is negative 1. So I'm going to divide 4 over negative 1 equal negative 4i. Negative 1 over negative 1 equal positive 1. We can write this number as 1 minus 4i. It's up to you. This is the form that he asked about. Okay, number 2 over 1 plus I. Here the denominator included a complex number. To change the complex number into real number, so we have to multiply up and down by the conjugate. So I am going to multiply up and down by the conjugate, which is 1 minus I up and 1 minus I down. Okay, down 1 times 1 equal 1. I times negative I equal negative I power of 2. Negative I power of 2, change the sign, equal positive 1. Here 2 times 1 equal 2. 2 times negative I equal negative 2i. Okay, 2 over 2 equal 1. Negative 2 over 2 equal negative 1i, which is negative I. You can use calculator to simplify, it's okay. This is 3, this is not 5. Excuse me for this wrong. Okay, now number 3. 3 plus 4i over 5 minus 2i. I'm going to multiply up and down by the conjugate of the denominator. 5 plus 2i and 5 plus 2i. Okay, here we have, okay, the denominator 5 times 5 equal 25. negative 2i times positive 2i equal negative 4i power of 2, and I power of 2 change the sign, it will be positive 4. Okay, here 3 times 5 equals 15. 3 times 2i equals 6i. 4i times 5 equals positive 20i. And 4 times 2i equal 4 times 2 equal 8i power of 2. Okay, here 8i power of 2 changes the sign, it will be negative 8. Negative 8 plus 15 equals 7. 6 plus 20 equal 26i, positive 26i. Down 25 plus 4 equal 29. Okay, so 7 over 29 equal 7 over 29 plus 26 over 29, it will be 26 over 29 I, and this is the number in the simplest form. Okay, you can check by the calculator. This is 25. This is not okay. Okay, next. Here number 4, 3 minus 4i times 3 minus I over 3 minus 4i. Okay, now I will multiply up and down times the conjugate, but before multiplying times the conjugate I need to simplify the numerator. It will be 3 minus 4i, and here 3 times 3 equals 9. I times negative I equal negative I power of 2. I power of 2 changes the sign, it will be plus 1. So it will be 10 over 3 minus 4i. Now I'm going to multiply up and down by the conjugate of the denominator. 3 plus 4i up, 3 plus 4i down. Okay, it will be 3 times 3 equals 9. Negative 4i times positive 4i equal 4 times 4 equals 16, equal negative 16 times I power of 2. I power of 2 changes the sign, it will be plus 16. And here 10 times 3 equals 30, and 10 times 4 equals positive 40 I. Okay, it will be 30 plus 40i over 25. It will be 30 over 25 equals 6 over 5 plus 40 over 25 equals 8 over 5i. Next, 1 over 1 plus 2i all power of 2. I will expand this bracket, all power of 2. 1 power of 2 equals 1. 2 times first times second equal 4i. Second power of 2. 2 power of 2 equal 4. I power of 2. I power of 2 change the sign. It will be negative 4. So it will be 1 over 4 minus 1 minus 4 equal negative 3 plus 4 I. So I will multiply up and down by the conjugate. Negative 3 minus 4 I, negative 3 plus 4 I, and you can change, you can simplify. Finally it will be negative 3 over 25 minus 4 over 25 I. You can check by the calculator, it's okay. Example 6. Find the value of x, y that satisfies the following equations. Number 1, x plus y I equal 3 plus 2i plus 2 minus I. This is the equation. Okay. In this equation, I will simplify this one. 3 plus 2 equals 5. 2i plus negative 1i equal 1i. So it will be I. Here, x plus yi, the imaginary equal the imaginary and the real equal the real. So x equal 5 and y equal 1. Numbers 2. 2x plus 1 equal plus 4y I equal 5 minus 12i. Okay, that means 2x plus 1 equal 5. Okay, so by sending 1 there as minus, it will be 4. Then 2x equals 4. Then x equal 2. And here 4y equals negative 12. I will divide it by 4, then y equals negative 3. Number 5, this example, 2x minus 3 equals 7. I send 3 there plus, then 2x equals 10. Send 2 as divide, then x equal 5. And 3y plus 1 equals 10. Send 1 as minus, then 3y equals 9. And send 3 as divide, then y equals 3. Okay, 2 plus I times 2 minus I over 3 plus 4i equals x plus y. Okay, now I'm going to simplify the left side here. 2 times 2 equals 4. I times negative I equal negative I power of 2. I power of 2 changes sign, it will be plus 1. Over 3 plus 4 I. Multiply up and down times conjugate 3 minus 4i. 3 minus 4i. Okay, it will be the denominator 3 times 3 equals 9. 4 times negative 4 equals negative 16. I power of 2 change the sign, plus 16. Up 5 times 3 equals 15. And 5 times negative 4 equals negative 20. I. 15 divided by 25 equals 3 over 5. Minus 20 divided by 25 equals 4 over 5 I. Now this is a number in the simplest form. This number, therefore, from this number, this is x and this is y. X equal 3 over 5 and y equals negative 4 over 5. Example 7. In this example, 7i equals 3x 7i equals 3xi times y minus I minus 9. Okay, find the value of x, y, which satisfy the previous equation. Okay, 7i equal x times y xy, x times I positive negative xi, and 3i times y plus 3i, and 3i times negative I, 3 times equal negative 3i power of 2, I power of 2 changes sign, positive 3 minus 9. Okay, here 7i equal xy. I will take from here, I will take I as a common factor, then it will be plus negative x plus here 3i times y equals 3yi. I take y as a common factor, it will be plus 3y I, and here 3 minus 9 equal negative 6. Okay, to make a balance in this equation, I will send negative 6 there. Then 6 plus 7i equals xy plus negative x plus 3y I. The real equals the real, the imaginary equals the imaginary. Okay, so negative x plus 3y equals 7. This is the first equation. And xy equals 6. This is the second equation. We have studied this concept or these two equations in the third prep. Okay, here from this one we get that by send x here and 7 here, then x equal 3y minus 7. This is the first equation. By substitute from the first in the second equation, so y times 3y minus 7 equal 6. Distribute y, then 3y power of 2 minus 7 y minus 6 equals 0. Now we have this equation. I will factorize by using the calculator. 3 equal negative 7 equal negative 6 equal, then x1 equal 3. Here the equation is y and the other value is negative 2 over 3. So y equal 3 and y equals negative 2 over 3. Back to this equation. Here x equals 3 times 3 minus 7. Then 3 times 3 equal 9 minus 7 equal 2. Then x equal 2. Or here x equal 3 times negative 2 over 3, which is negative 2 minus 7 equal negative 9. So x equal negative 9. Okay, now let's take a summary for the lesson. And this is the end of the lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.